Right, in this video clip we're going to look at algebraic fractions, which predominantly is revision for you. Certainly you would have covered this in the higher tier GCSE, although the algebra becomes a little bit more difficult. And what we need to do before we tackle these questions is just to try to translate them back to when you're working with fractions, numerical fractions that you would have met early on in your Key Stage 3 education, if not before. So if we are simplifying fractions, if we think back to something like a fraction where the denominator is 12, sorry, the denominator is 15 and the numerator is 12. What we would be doing in Key Stage 3 is looking for numbers that would divide into both of those, looking at things that would cancel in. But that wouldn't be something that you could do with an algebraic fraction because there isn't a times table you could deal with. So if we think of writing these as factors, then what you'll see is the top factor there we could write as 3 times 4. You could break the 4 down further, and the bottom one we could factorize as 3 times 5. So we have a common factor in both the numerator and the denominator, and that means we can divide throughout by that common factor, which we say we're cancelling. So if we can factorize our expressions and there are common factors on the numerator and the denominator, then they will cancel, and that in effect leaves us 1 times 4 on top, which is 4, 1 times 5 on the bottom, which is 4/5. So again, if we've got an expression like 18 over 24, numerically we would divide, and we may just say, well, those are both even, so we can divide both by 2. So if we're dividing by 2, we're left with 9 over 12. Oh, those can be cancelled further again because 3 goes into both. 3 divides into 9, leaving 3. 3 divides into 12, leaving 4. So those are our equivalent fractions. If we think of that as a factor straight up, 18 we can write as 2 times 3 times 3. 24 we can think of as 2 times 2 times 6. And we can see there, which we can write as 2 times 2 times 3. So again, what we have are common factors that we can cancel. We can cancel one of the 2 in the numerator with 1, 2 in the denominator, 1, 3, 1, 3, leaving us 3 on top, and 2 times 2 is 4 underneath. So that isn't what we would have done at Key Stage 3 because our knowledge of our times tables enables us to do it more rapidly than that. But when it comes to algebraic terms, algebraic fractions, in order to cancel, we need to factorize wherever possible the numerator and the denominator, and where there are common factors, that's what we can cancel. So let's take a look at these questions. So the first one there, simplify x squared plus 1, sorry, x squared minus 1. Well, one of the quadratic forms that you should learn to spot is if you've got a squared term minus another squared number. So x squared minus 1, x squared minus 4, x squared minus 9 is something that you can write straight down, hopefully, you will remember, as x minus 1 x times x plus 1. It's called the difference of two squares. So A2 maths, hopefully you can recognize that. Then on the denominator of this fraction, it's a more standard quadratic that we're looking to factorize. We're looking to get two numbers that multiply to give 3 and add to give 4. So that's going to be plus 1 and plus 3. And then once they've been factorized, we can cancel any common factors. So we can see there that we've got an x1 as x plus 1 on the numerator and an x plus 1 on the denominator. So that simplifies to x minus 1 over x plus 3. With this second one, I've got another difference of two squares there. So that is going to become, but this time it's going to be 1 minus x, 1 plus x. And the denominator has already been factorized. And we're multiplying that by 6x squared. And here we have another quadratic expression, but backwards to what we'd be comfortable with because it's got a negative x squared term, but it's still going to be a double bracket, and it means that we're going to have a 2x and an x to get that 2x squared, and one of those is going to be positive, one of them is going to be negative. The product to produce the number only part is 3, so it can only be 1 and 3. It's just we've got to make it the right way around in order to get that. Now, if that was 1, then I would have 3 there. So I would get, I need a plus 3, so that's 3. Then to get the plus x, that's going to be 6x, whether it's positive or negative. And that's going to be an x. So there's no way that's going to combine to give me a plus x. So that is going to be 3, and that is going to be 1. So then I just need to work out the signs correctly. I need positive 1, so I need plus 3 minus 2. So I think that's going to give me what I need. So just check it through. First 3 plus 3x minus 2x is plus 1x minus 2x squared. So that's what that looks like. Now when you cancel in common factors, you could combine all of that now, or you could leave it broken with a multiply. It doesn't matter. What you're doing is cancelling anything that's common on top with anything that's common on the bottom. So I can see straight over there I got the 1 plus x, so that's going to cancel. I've also got 4 and 6, which I can divide both by 2. 4 divided by 2 is 2, 6 divided by 2 is 3. Nothing else is going to cancel, so that leaves me on the numerator. I've got a 3x squared times 1 minus x. And on the denominator, I've got a 2 bracket 7 plus x bracket 3 minus 2x. And when you're simplifying, you wouldn't tend to multiply those brackets out, you'd leave them like that. So the third example is a division of fractions, and hopefully you will remember from again Key Stage 3 that when you divide it by a fraction, it's the same as multiplying by its reciprocal, which means turning the divide by part upside down and multiplying. Now with this one, I've deliberately picked one where it's not actually a fraction, but you can write it as a fraction by putting it over 1, because anything over 1, it doesn't change the value. So when we are going to simplify that, we're going to multiply by its reciprocal. So on top, we've got 3n minus 9. Well, I can take a 3 out of there as a common factor, leaving n minus 3 over n. And then I'm multiplying that by 1 over n squared minus 9. Here, square, that's a square number, so that's a difference of 2 squares. So I can write that as n plus 3, n minus 3, and it's important that you hunt down the difference of 2 squares and make sure you spot it to be able to deal with. Okay, then we can go and cancel our common factors, which in this case is n minus 3, leaving us on top 3 times 1 is 3, and denominator n bracket n plus 3. Job done. So multiplying and dividing algebraic fractions, you're looking for common factors to divide throughout by. Okay. Then we come to addition and subtraction. And again, it's worth going back to consider what we were doing with numerical fractions in order to move on to algebraic fractions. So if you consider a fraction such as 3/4 plus 1/6, what you would have been taught to do in Key Stage 3 is to turn these into equivalent fractions which have got the same common multiple. So you'd be looking ideally for the lowest common multiple. So a shortcut method you would have probably been shown is if you multiply those two together, you get 24. That will give you an equivalent fraction, and it will, but it won't give you the simplest equivalent fraction. So if we did that, let's just look, maybe this is how you would have been taught. You might have been taught, right, you're multiplying those to give you your equivalent fraction, and then on top you do that times that plus that times that to get 18 plus 4, which you would then simplify to get 22 out of 24. That's not in its simplest form, so you can cancel it down to get 11 over 12, dividing both by 2. So that might have been a method that you were shown, and that method actually often does work with algebraic fractions as well. However, there are occasions when you need to be mindful of what's happening with the denominator. In the same way, that method doesn't produce the lowest common multiple as the denominator. If you had been doing that and looking for the lowest common multiple, you'd have been again using your tables knowledge to find out what's the smallest number that lives in both the 4 times table and the 6 times table, and got 12. Another way of looking at it, which is more helpful when it comes to algebraic fractions, is if you break these down into their products of prime factors. So this one we've got is 2 times 2. This one is 2 times 3. What you're looking to do is to make these the same. So in order to do that, I have to multiply this one by 3 and this one by 2. Then they're both out of 12. So I'm looking at what's in this one and not in that one, and vice versa. And because we want to keep the fractions the same, if we're multiplying this one by 3, if we multiply the denominator by 3, we have to multiply the numerator by that as well. And similarly over here, to maintain the balance, I have to multiply top and bottom by 2. So what you end up with here is 9 over 12. 3 times 2 is 4 times 2 is 12. And here, 2 over 12, which gives you 11 over 12. So it's the same thing. The difference is, this is what you'll be spotting in algebra because you haven't got your times tables to be able to deal with. So you're looking at what the factors are in each fraction, and then what you have to multiply them by to make them the same from the other part of the fraction. Let's see if I can make sense with the examples. So express as a single fraction. So the first thing I want to do here is to factorize that. So when I factorize that, I get 3 over 2x plus 5 for that first term. And then for the second term, x minus 7 over, and I can take 2x out of that as a common factor. And when I do that, I'm left with x plus 5 as the other factor. Check that's right by multiplying it. Sorry, no, it's wrong. It should be 2x plus 5. So check 2x times 2x is 4x squared. 2x times 5 is plus 10x. So what I'm looking to do now is to come up with a denominator that contains all the factors common to both. So hopefully you can see that in order to make that one the same as that, I have to multiply by 2x. And if I multiply that by 2x, I have to multiply that by 2x as well. And to make that one the same, I don't actually have to multiply it by anything, because they now have the common denominators. The common denominator is 2x bracket 2x plus 5, and then the numerator is going to be 2x times 3 is 6x plus and just x minus 7 there. We can then tidy up the top. 6x plus x is 7x minus 7 over 2x bracket 2x plus 5, and you could leave it like that, or I've noticed I can take a 7 out as a common factor. X minus 1 over 2x bracket 2x plus 5. So you need to be careful when deciding on what your lowest common denominator is going to be. You're looking for what do you need to combine from each part in order to get these equivalent fractions. The bit in green there, once you've decided what that's going to be, another way of doing it is to say, right, if I'm dividing this into that, what's left? So 2x plus 5 is going to cancel with that, leaving you 2x. That is then what you have to multiply by 3. And when I divide that into that, it goes once, so 1 into that gives you that. With the second example there, which is a subtraction, this is more like that method, because there are no factors within one which are also appearing in the other. So with this one, the denominator is going to be 4x minus 5 multiplied by 6 minus 2x. The numerator, if I divide that into that, it leaves me that. So I'm going to have 3 times that. Minus, if I divide that into that, it goes in, leaving me that. So it's going to be 2 4x minus 5. Tidy up the numerator by expanding the brackets. So 18 minus 6x. You have to be careful here with the minus outside. So it's going to be minus 8x and then plus 10 all over that. I have 18 plus 10 is 28. Minus 6x, taking off another 8x, is going to give me minus 14x all over the denominator. And I can take 14 out of that, giving me 2 minus x all over 4x minus 5 over 6 minus 2x. Okay, so those are the examples we will be going through in class, and then hopefully you can get stuck into exercise 7b.